Alright, let's do this. Advent of Code, day 18. Yesterday I couldn't do day 17. Spent 5 hours on stream and a few hours after that alone. And still can't figure it out, so it's very much painful. God damn it. Yeah, that was annoying, especially since in 2021 I struggled on the same kind of problem. So, yep. I mean, I did learn about Dijkstra, so that's nice. Anyway, day 18. Thanks to your efforts, the machine parts factory is one of the first factories. The machine parts factory is one of the first factories up and running since the lava fall came back. However, to catch up with the large backlogs of parts requests, the factory will also need a large supply of lava for a while. The elves have already started creating a large lagoon nearby for this purpose. However, they aren't sure the lagoon will be big enough. They've asked you to take a look at the dig plan, your puzzle input, for example. This, okay. Those look like hexadecimal codes for colors. The digger starts in a 1 meter cube hole in the ground. They then dig the specified number of meters up, down, left or right, clearing full 1 meter cubes as they go. The direction are given as seen from above. So if up were north, then right would be east, and so on and so on. Each trench is also listed with the color that the edge of the trench should be painted as a RGB hexadecimal code. When viewed from above, the above example dig plan should result in the following loop of trench having been dug out from otherwise ground level terrain. Okay, at this point the trench could contain 38 cubic meters of lava. However, this is just the edge of the lagoon. The next step is to dig out the interior so that it is 1 meter deep as well. And that is definitely flood fill, or at least it looks like it. And now the lagoon can contain as much as more respectable 62 cubic meters of lava. While the interior is dug out, the edges are also painted according to the color codes in the dig plan. The edges are also painted according to the color codes in the dig plan. The elves are concerned the lagoon won't be large enough if they follow their dig plan. How many cubic meters of lava could it hold? I understand that I have to dig and I have commands to dig in some direction, but I definitely did not understood what the color is for. I mean, it colors the edge, but what am I supposed to do with this information? So each trench is also listed with the color that the edge of the trench should be painted as an RGB. Okay. While painting while the interior is dug out, the edges are also painted according to the color codes in the dig plan. So, okay, I guess for part 1 it does not matter, I would guess. So let's get the example. Xclip example. For line in again do this strings split line iterator, and I have to do a plan, and it's like, for example, let's just call this command command is a struct that has a direction, that has a direction, wait, direction is this, and let's set it as a rune. It could be an enum, but I don't really care. And I don't know, meters is an int, and I don't know, color is a string. Sure. So what I want is direction is something, and then meters string is equal to strings, I don't know, it's rest strings partition of line. Then we have meters string space, and then we have color, which is again strings partition of I have to put a separator here, and it's rest, and then the separator. And then I have a command that is direction 0. I have to assert that len direction is equal to 1. Yeah. And then I have need to import string conversion, and then it's strconf toy meters string, and the third one is a color, which is just a color. Wait, actually, strings trim. Need to trim from color. Let's trim out the parentheses, and the trim allocate something. That's right. And then we need to do commands is a dynamic list of command, and we do append commands this, like so. Oops. Up. And why doesn't want to run? Can it assign value of type U8? Oh, I mean U8 is fine as well, no? U8 is fine as well. Okay. Fancy println comments println. So that looks about right. Example. Okay, it's a bit actually annoying that this is. I would like to be able to read it. Rune. Okay, so error 6 and this, and D5 and this. Okay, that's perfect. Then the digger starts in a 1 meter cube hole on the ground. They dig the specific number of meters up, down. So it digs right for 6. So I guess it starts here, and then 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6. Okay. Then it goes down, I guess. Down 5, and then left. Okay, left, and then down, and right. Okay. Then down again, then left again, then up. Okay. And the puzzle input is quite long, I guess, huh? Okay, so I'm not sure. I'm not sure I actually want to like store a grid of all of these. It might be better to just store the edges. But how do I do my float fill then? Not sure. I wonder if this is not like oops, area of a polygon. Area of a polygon. Oh, that's a regular polygon, but I have an irregular polygon. Okay, but what if I just don't like... We divide the polygon into 2 or more regular polygons. Okay. Can I do that automatically in my case? Because it's, I mean, we know it's gonna be rectangles. That sounds quite hard to do. So yeah, I have something like this, and I can obviously, I can split it up, but is there like a programmatic way of splitting it up? Okay. Algorithm. Area of polygon. Okay. Stack Overflow. The standard method. Algorithm for area of a closed polygon. Let vertices be an array of n pairs. That's what I'm gonna have at the end. Let area be 0, 0 for I until n minus 1. So we iterate over the vertices. Let j equal I plus 1 mod n. So... okay. So we pick the next... we pick the next vertex. Let area is equal to area plus vertices. So this times this, and area minus vertices minus return area. As long as your polygon has no self-crossing or internal holes. Definitely no internal holes, but self-crossings. Not sure what that is. Polygon self-crossing. Self-intersecting. Self-intersecting polygon, crossed polygon, or self-crossing polygon are polygons, some of whose edge cross each other. They contrast with simple polygon whose edge never cross. Intersect with itself. Whose some edge cross each other. Then, like I mean, I'm pointing to my screen, but the red one in this picture looks like a crossed polygon, no? Oh, okay, okay. So red is not a simple polygon. So red is okay, but I don't have this, so it's fine. Okay. As long as your polygon is, let me zoom in maybe. As long as your polygon has no as long as your polygon has no self-crossing or internal holes, this algorithm is probably the simplest. It will return twice the signed area of your polygon. the vertices be an array. Okay, that seems very simple, but I didn't not understood why it works. Because so there is a bunch of vertices, and you're taking each pair of it and multiplying draw online. Is there like a sketch that looks quite scuffed? Okay, so let me draw a random thing. Just unfortunate the background is shitty, but whatever. Let's draw. That's my polygon. That's my drawing with a mouse is annoying. So this is x1 y. God damn it! I hate drawing with a mouse. And x2 y2. And then what it does is it takes this pair, and it's gonna take every single pair after that, but okay. And then what he does is, oops. So x times y. So he does this times this minus this times this, and so this times this is what is would be so x1. So let's say we have the xy axis like so. This is x, this is y, this is 0, 0, and so x1 would be this. I mean, I'm doing a terrible job of. Maybe I should be doing it like so. X1 would be this. Is there like? Is there? Oh, normal. Okay, let's not play with this. Whatever. But maybe I don't know. Just another color for my sanity. Up, like so. Yes, that's good. So x1 is this, and y1 is this, and so this times this. This would be this. Let's say we report this here. I mean, this is approximative, so it would be all this area. Okay, this looks very scuffed. All this area, and then we have y1 and x2, which will be this. Okay, so like we're computing a square and we're removing part of it. I wonder if the end goal is not to have something like for this edge, we just compute this area. For this edge, we compute this. For this, we compute like so. Oops. For this, we compute this. For this, we compute this. Like we split the polygon like so into these 1, 2, 3, 4, 5, 6 region, and yeah. I'm not sure to understand why this minus this. Maybe it would be easiest to understand for this one. So Oh. Actually, does this with the background, does this look horrible on stream? I think it does. Can I? Oop. Yeah, it kind of looks horrible. But anyway, yeah, I'm just curious, but let's use this blindly, like a true programmer, and not think about it. If the vertices of your polygon are specified in counterclockwise order, i.e. by the right-hand rule, then the area will be positive, otherwise the area will be negative, assuming the polygon has non-zero area to begin with. Hope this helps. Send another note for the mailing list if not. Basically, sum the cross product around each vertex. Sum the cross product around each vertex. But I thought the cross product was the way to get like the orthogonal vector in 3D space. Why is it applicable for area in 2D? Python can given a polygon represented in a list of x, y vertex coordinates, implicitly wrapping around the last vertex from the first. Is worth mentioning why this algorithm works is an application of Green's theorem for functions minus y and x, exactly the way planimeter works. More specifically, integral over parameters, integral is equal integral over area is equal to 2 area. Green's theorem. In vector calculus, Green's theorem relates to a line integral around a simple closed curve C. Okay, I am definitely not going to understand this. I am definitely not going to understand this. All right. So the only thing I need now are the edges. So we do, no, the vertices, oops, vertices like so, is again a dynamic, actually, shouldn't the vertices be exactly the same size as commands? It should be, yeah, I think so, huh? It should be make a slice of positions with len commands. Maybe len commands, just len commands. Yep. Then we do vertices 0 is equal to 0, 0. For commands in for comment in commands we do This will be useful for vertices. We do switch on command direction, like so, and we do case. Oops. Case U. So we have down, we have left, and we have right. And so what we do is this is needs an I as well here. We do vertices I plus 1. Maybe I need to make this len plus 1. Vertices I plus 1. So yeah, let's do this here. It's equal to vertices I. And then vertices I plus 1, and here it would be y. Yeah. And this would be minus command meters. And then up, like so, like so, like so. And here it's x. And here it's a plus, and here it's a plus, and up. Okay, and any other case, we panic, invalid direction. Expression is not used. Oh, yeah, I need to do minus equal. Okay, let's try this. So, let's compare this to the example. So we start at 0, 0. Start at 0, 0. Then we go to 6, 0. That makes sense. Then we go to 6, 5. That makes sense. Yeah, okay. Yeah, that makes sense. Except I do not have 0, 0 here. I do not have 0, 0 here. I mean, I have 0, 0 twice, is what I mean. Actually, maybe that's fine. Huh? Maybe that is fine. And then I just need to do for vertex I in vertices. I have a sum that is, no, let's call it area, which is which starts at 0. And then, what was it? Vertex, and we need to go up until len vertices minus 1. Like so. I think we need to ignore the last one. And so this is this time vertices. Let's do next is equal to vertices I plus 1. And then next y, then area plus equal, and then area minus equal y x, and we print area 84. Oh, this is definitely not it. This is supposed to be 62. This is supposed to be 62. How many vertices do I have? Let's do a quick sanity check. Print ln len vertices 15. Let's see. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, I mean, of course I counted this twice. And it did say that maybe I need to do this. Minus 84, okay. Um, let's print I. Goes until 13. So this is 14 edges, so that's good. Did I miss something? Area plus vertices I. J is equal to I plus 1. So this is like 1, 2, 3, 4, 5, 6, 7. 7 times 3. 7 times 4. 7 times 5, that's 35. 35 times 35 plus 15, which is 50, yeah. 50 plus 12 is 62. Okay. Why do we have 84? Why do I have 84? Maybe it's because I'm counting these twice. This point, the trench could contain 38 cubic meters of lava. However, this is just the edge of the lagoon. Is to dig out the interior so that it is 1 meter deep as well. And maybe, what if I remove all this? 1, 2, 3, 4, 5, 6, 7, 8. What if I remove only the ones that are right or down? Wait, 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11. Wait, what is the difference between 84 and 16? And 62. It is 22. 22. So it's not 80. It's not 38. So 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Hello! How are you doing? I'm trying to compute the area of this, but the random, the algorithm I found online is not really working for me. Yeah, I'm doing good. I mean, I'm traumatized by the problem of yesterday, but that was bound to happen any day now. Huh? So yeah, but I mean, besides that, I'm doing fine. Still didn't. I mean, I kept thinking about it yesterday, but I didn't find a solution. So yeah, it was fun to learn about Dijkstra though. I mean, I know it existed, but I never implemented it before. Are you doing Advent of Code yourself, or just enjoying watching Odin programming? Oh no. Alright. Aren't you curious about it? Just watching you doing stuff. Alright. That's nice. Okay. What if I do every single... That doesn't change anything. That's strange. That is strange. So yeah, if you don't know the problem of today, we are basically digging something, and they give us commands. Like for example, the machine is gonna go right 6 squares, and then down 5, and then left 2, and so on and so on. So it's just in which direction and for how long. And then at the end, it draws something like this, like so. And you have to compute the area of it. And I mean, my first instinct was just represent this whole grid in memory, and then do a float fill on it. If you don't know float fill, it's an algorithm float fill to fill something. So I don't know if there is useful GIFs. So yeah, that's how you float fill one area without going outside of it. And that would be an easy way of solving this, but I'm afraid that for the actual input, I'm not able to draw such a thing. Yeah, it's a pretty nice algorithm. But yeah, I was afraid that I wasn't going to be able to represent this in memory. So I searched for like an algorithm to do the area of a polygon. And I found this, which seems really simple, which is, I don't understand how it works. I try to understand it here, but I'm terrible at math, and I got lazy, so I just wrote it. But it doesn't work, and I'm not sure why. And I suspect this is because it includes maybe some edges 2 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20. Huh. So I know it doesn't like count twice all the edges, because my difference between so my actual area that I compute is 84, but what I'm supposed to get is 62, I think. Yes, and we know that all the borders have a total of 38 cubic meters. 38 cubic meters, but my difference is my difference between the actual answer is 22 cubic meters. I mean, they call it cubic meters, but you know what I mean. Like, it's just a cubic meter is a square. Is 1 square. And so I have yeah, I have 22 too many, and I'm wondering if there is maybe like some of those that I'm counting twice. How about let's count all the horizontal one? 1, 2, 3, 4. So this is 7, yes. That's it. 10, 13, 16, 21, and 27. So that's not it. Let's count all the vertical ones. This is 3, then 1, 2, 3, 6, 9, 10, 13, 13 plus 3, 16, 19, 22, 25. Still not 8. So I assume it's like either... so it does this. It is counting all horizontal to make it 38. No, it's to make it 38, it's just counting all the edges. Which I can do, huh? But the problem is at the end we want the area of it. We just don't want like the actual edges. Maybe I could do something simpler by making the shape one outside of it. I mean, I'm explaining this badly, but what I mean is, like, if I would have if I have this, if I instead do this and then like draw one outside every time. So yeah, maybe that could work. Like my actual shape, my actual list of vertices would be one that is just outside instead of the current one. And to do this, I would just have to do -1 here, +1 here, -1 here, +1 here. That doesn't look correct. That doesn't look correct at all, but nope. It is not correct indeed. It is not correct indeed. Vertices. So I go 0, 0, then 7, 0, so which is here. Actually, I don't want this. Okay. So I want to start at -1, -1 then. But then that's not good either. That is not good either. Because then I will want to do +2. 7, 1 looks good, and then 7, 6. Yeah, but like this is terrible. So if I start 0, 0, I do this, then go until the 7th. So I go from 0, 0, which for me will be here, then to 8, 0, and then I go to 8, 7, which is 0, 1, 2, 3, 4, 5, 6, 7, which is good. And then I go to 8, 7 again. Wait, what? Why do I have 2 times 8, 7? Wait a minute. Actually, I think, okay. I think I'm supposed to do pluses here. Okay, that's definitely not good. That's definitely not good either. Okay, let's give up on this. Back to 84. Do I give up on my idea of computing the area cleanly and just make a big grid? In memory and do float fill. Hmm. Hmm. I really feel like okay. I really feel like this could be easier. Dum, dum, dum. Mm, am I like computing too much of this? No, that sounds even worse. What if I do this modulo len vertices 84? Okay, that doesn't change anything. Now that the lagoon contains a much more respectable 62 cubic meters of lava, while the interior is dug out, the edges are also painted according to the color codes of the deck plan. Those that are concerned about the lagoon won't be large enough if they follow the deck plan. How many cubic meters of lava could it hold? I think 38 is this, right? 7, 9, 13, 15, 17, 23, 25, 30, 32, and 32 plus 6, 38, yes. Is there a way to make this go one lower? What if I start in Y1? That's very strange that it's still an area of 84. And inputs. Yeah. Input seems pretty big, but I don't know. Yeah. Let's see. Okay. Oh, now there is minuses as well. But let's print. Actually, that doesn't look that big, huh? I bet I could actually represent this in memory. So let's. It says the area here is like 100,000 almost, but I'm not sure. Let's do, instead of this, we want to print min and max. Max. Oh, can I do slice? Oh, fuck. Oh, whatever. It's terrible, but it's just to understand if I can put it in memory. Vertices, vertices. Is equal to min vx max is equal to max of this and max and minima. Oh wait, min is supposed to be the large one and this is supposed to be minus the large one. Okay, so it goes from minus 225 to 290, which is about 400, huh? So not that bad. What about the y coordinates? Yeah, again, it's about 300, so 300. Yeah, this is actually this looks like a decent guess, huh? So the total area of the minimum enclosing square of this pattern is 120,000. And the fact that this guess is almost right makes me want to keep going with the area stuff, because it would be an elegant solution, and I would be happy if I can make this work. So, let's go back to the example. No, not Python. So, I have 84, I'm supposed to get 62. Let's do up sum. I want to count like how many squares am I going in each direction. Again, just for debugging, down, left, right. And if any combination of those is actually the difference between my answer and the correct answer, which the difference is 22. So we would do up sum plus equal to this. And then like so, whoop. This is down, this is left, and this is right. And here I want to print ln up sum. Why don't I have autocompletion? I don't know. Actually, let's make this a bit smaller. Down, left, sum, right, sum. Don't have left? Ah, yes. I forgot the sum. Wait, 18. Oh, fuck. None of those make a total of 22. Those almost do, but this is left and right. But yeah. Isn't it just 18? No, like 19 plus 3 for the corners? That looks like I'm trying to do a magic trick, huh? Not really programming, but... Can I do minus? And like it would be up, sum, plus, left, sum, I mean whatever, plus left, sum, and all of this minus 3. Yeah, this is very hopeful, and I have no clue if this, I don't think this will work, but let's try it, because I have nothing to lose. So this. That's not the right answer, of course. Your answer is too high. Okay. Whoops. That's too high. And the initial guess was this. Okay. The initial guess was this. Could it be this? Like, only the ones that are in a certain direction, so would mean like, whoops, this, and then this. Could it be like all of the top and right ones? So 7, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22. But that actually is correct. No, wait. 7, 9, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That's almost right. That is almost right. What about like all of those? So this is like 38 divided by 2. No, that's not correct. 38 divided by 2, which is 19. Because, yeah, what I just said actually does make a bit of sense. Since we're doing, how do you say? Discrete mathematics? What do you call it? Discrete math. Discrete mathematics. Like it's mathematics, but only with integers, I think. And I think the area algorithm is for, non-discrete, like real numbers. So I think removing part of this edge. The answer, yes, the answer should be 62, and I'm having 84. And my train of thought is removing all the edges on one side because I'm counting them twice, I think. So this would be up sum plus down sum plus right sum plus left sum, and all of this divided by 2, which will not be correct. Wait, no, because I want the example. Example 65. Oh, wait, 3. Arithmetic, pentagon, let's see. Up, oops. Up. Like so, like so, like so, like so. So, wait, I have too much weird prints. So this is 38 is the length, the area of the edges, and if we divide this by 2, we get 19, which is 3, almost what you want. Okay, so no, this is not the value I wanted, but the stuff I was talking about earlier is, I think, correct. So if I count only this, 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 and this, like so, that I think should be correct. And to get those values, what I need is fuck. How do I get all the... Like, let's get back to like the drawing. Can I have a new ones? And can I have like not like a shitty background? That would be nice. Draw. Sketchpad. Auto draw. Quick draw. Draw.io. What is Draw.io? Start. Yeah, oh, for fuck's sake, I don't care. Let me just draw, decide later. Thank you. Can I have this? And can I have just a line that I don't care about? Like, can I just draw stuff? Flowchart, basics. I don't care about the... Okay, fuck it, let's go back to this one. Can I just cancel all of this? Up, and then I want a bigger line width, like so. And black, yes. So I have a shape that is whatever, some shape. Like so. And I think I'm computing the, like, half of the edge 2 times, but half of the edge in this direction. So I would like to have like some kind of eye here that watches only this, and that gives me only these edges, those edges, and not the other ones. So not the red ones. And I don't know, it makes sense in my mind because it makes somewhat sense in my mind. So how would I know this? Because this can be, of course, any direction. This can be up, up, right. In my case, I just did up, right, because I was lazy, but here you can see it's up as well, so. And in their example, yeah, okay, there you can see here it's going actually right, but I want to see this one as well. So yeah, a better example would be like if I had something like this here, and is there like a eraser? Yes, like so. Boop, 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 boop. And till up like so. How do I only get those edges? Rotate the polygon. Rotate it. I mean, I understand I can rotate it, but I don't understand how that would give me what I want. Like if I rotate it, like, I mean, that doesn't give me much new information, I feel like. What do you want to extract with the rotation? Couldn't I just, when I build this polygon, keep a Boolean variable that is true at the beginning, so we can see this one. And if we go down, we flip it. If we go up, we don't flip it. If we go right, we don't flip it. If we go left, we flip it. What would it be? Flip it, flip it. Yeah, that already doesn't work. That already does not work. And am I not able to go -1 in this direction? If I go -1 on the right and down, so here I go, maybe I could also shrink the polygon slightly. Let's pick another color. What if instead of drawing this, I start here, I draw until there. So only right and down. So this would be the same length. Down would be one shorter. This already wouldn't work. So I need to start one shorter here and one shorter here. But here I cannot go one shorter, otherwise it won't work. If I go left should be the same, right? This should be the same size, this should be the same size. Uh, mm, yeah, that sounds a bit stupid, but I would still like to try it. So, if I is lower than 2, we do command meters minus equal 1. Did you look into Pick's theorem? That sounds like a meme. Pick's theorem. Pick's theorem. Geometry Pick's theorem provides the formula for the area of a simple polygon with integer vertex coordinate. Ooh, okay. That sounds like exactly what I want. Because yeah, this is for integer vertex, and I have my formula is for real numbers. So in terms of number of integer boundary, English, mathematical snapshot. Formula: suppose that polygons have integer coordinates for all of its vertices. Let I be the number of integer points interior to the polygon, and let B be the number of integer points on the boundary, including both vertices and points along the side. Then area A of the polygon is so I be the number of integer points interior to the polygon. Okay, but I still need to compute the number of points that are inside of it. I guess I could just go line by line and like count. Yeah, that would be way simpler actually. That would be way simpler. But I don't know. I need to get all the points that are count the number of integers. And let B be the number of integer on its boundary, including both vertices and points along the sides. Wait, let me try my quick scuffed thing first. Wait, like so, and then at the very end, let's just print area. Why? What did I do? Oh. Fuck, okay. My stupid trick doesn't work. My stupid trick doesn't work. Yeah. The polygon B is the number of integers. So the number of point on the boundary I already have. And now to get the number of points inside of it. Yeah, I guess I'm breaking my stuff. I'm breaking my head with math for no reason at all. What I'm gonna do is, I mean, it's kind of like this. I'm gonna count the number of points that there is inside of the shape, like in Pick's algorithm, theorem. But I don't think I even need this theorem because I already know just the number of points on the boundary, and I will know the number of points inside of it, and I just add those, and that's it. So I do for vertex in vertices. Let's comment all of this out. Vertices. What I need to do is no, I think I need to get the total the length, like the dimensions of the minimum enclosing square. So what I did in the beginning actually. So min x is equal to some large number. So and then max. Then we have y, and this is minus, and this is minus. And then we do min x is equal to min of vertex x, x and vertex x max up like so. This is y, 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 and this y, and this should be max. Okay, so I have the including square, and then what I do is I do for y for y in min y until max y, like so, maybe. Like so. So I iterate over, but that's like O3 complexity at the end, because I'm gonna iterate just over every single square of this. But computers are fast, so this shouldn't be a problem. And I computed the area of the actual input, and it's 120,000, so that's not too bad. Actually, maybe it's going to be bad, because here I want to do a third loop that will be for vertex plus v in vertices, and we know that in input there is let's say 675, and so that's 3 times this, which is a bit too much maybe, huh? Like so. This is 80 million. Computers are fast, but are they really that fast? Odin is an interpreted language, not at all. It's very much a compiled low-level language. I mean low level. I guess you can go low level, but there is also higher level construct in it. But yeah, if you want to do low level stuff in it, it's allowing you to do so very easily. Or at least as far as I know. I was able to do SIMD stuff very easily and stuff like this. Yeah, I guess maybe it's not as easy as C to do really, really low level stuff, but yeah, it's a fine language. Fine language. But definitely not interpreted. Does it say on this Wikipedia page, how am I supposed to count the number of integer in the polygon? Proof, other proof, generalizations. Related topics. Mm. Uh, area of this polygon. Yeah, I'm realizing that my tree loop thing isn't that smart. I mean, I knew it wasn't smart, but I think it's a bit too much to compute. I think it's a bit too much to compute. Discrete lecture, discrete geometry. They're talking Chinese. Structural, incident structure. Nope. Area of regular polygon calculator. Number of sides. That's a regular polygon, I don't have this. Generate discrete areas from multiple overlapping features. Polygon area. Side area of a polygon vertices. Yeah, I think that's kind of what I'm doing, but more math. Oh, how to create polygon. Nope, nope. Have you looked into shoelace formula? I saw this in this page, no? Shoelace formula at the end, yes. Another simple method for calculating the area of a polygon is the shoelace formula. It gives the area of any simple polygon as a sum of terms computed by the coordinate of consecutive periodicity. Ooh, it does look like shoelaces. The shoelace formula, also known as a Gauss area formula, is mathematical calculus area of a simple whose vertices are described by their Cartesian coordinate on the plane. Yes, content cross multiplying. I think that's what I'm doing actually. I didn't know it was called the shoelace formula, but I think that's what yeah, it's a sum. Wait, sum, not sum. Actually, that's not what I'm doing. Wait, no, that's something else. Shoelace formula. Which is a scheme that optimizes the calculation of the sum of 2D determinant by hand. But I think that's exactly what I'm doing. So he's doing like x1 times x2, x1 times y2 minus y1 times x2. And this is what I tried in the beginning. This is this. So I have an area, I have a list of vertices, and I'm doing every time plus vertex x times next y, and minus vertex y times the next vertices x. So yeah, I think yeah, I think I'm doing this, and this is almost correct. Like if I remove this chunk, oh, not the whole chunk, this, and I don't do anything strange. Let's print the area. So up. This is. Should you not have it? No, because this is 84, and the actual answer that I'm supposed to get is 62. And I think I know why it's not working. Is because the shoelace formula is for, I'm assuming, is for real numbers, I think. But in my case, I my stuff is for integers. And I think what's happening, it's counting like, where was my drawing? So I have a shape like this, and I'm assuming it's like counting one of half of the edges twice. Because if you count like this part of the edge, so imagine you have an eye in some corner in the top right corner, and you do the edge like this. This is actually sums up to 21, which is almost the difference between my answer and the actual answer. And I would guess that if I do like count this, should be as well, like, actually let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, maybe not. Maybe not. Should you not half hit? Hmm. You mean half like one of those? Maybe? I don't think that's doesn't make sense. Yeah, okay. But I'm almost sure it has to do something with the edges, huh? I'm almost sure of that. I was just thinking of the formula for polygon area. You mean do this formula on only half of the vertices? Or like the resulting area? But because, yeah, I don't think I can half the area. But I think this is almost correct. This is almost correct, but I'm not smart enough to figure out how to discard only those. Oh là là. Wait, can I just Google shoelace formula for integers? Why think about something when you can ask? Shoelace theorem. Yes. Other forms. Oh, you're right. There is a half in here. Why is there a half in there? This can be also written in the form of a summation. So it's half of the absolute but it says that it's the same. That's a regular polygon, maybe. Yeah, my polygon is definitely a regular polygon. I mean, I looked up the definition like 5 minutes ago, so I'm not sure. But wait, what is a regular? I think mine was like a simple polygon. I think the definition for wait, shoelace. So it needs to be a simple polygon, and the simple polygon is one that does not cross itself and does not have a hole in itself, which is my case. So this is a polygon, and it indeed doesn't have any crossing or holes in it. So I think the shoelace or like similar formulas should work. And I think it is because, but I'm curious about it because it says it's the same, but I'm confused about why. Oh, so it's doing something slightly different. It's doing. It is doing so. Area. So plus equal. So it's next x. No. Plus. Like this. Plus vertex x times all this, but why? Oh no, it's the next one minus. Okay, and then its area is equal to apps area and all of this divided by 2. This is 42. Okay, this is different, I guess. Still not the right answer, but did I copy-paste this stuff correctly? The sum of the next one plus x times the next one I minus the current y. Yeah. And maybe I'm doing this once too many times. So n vertices minus 1. 42 still. Alright, be right back. Wait, I was looking for area of discrete polygon. Copying the area of discrete points in MATLAB. But going back on Pick's theorem, so it says that I have to have the number of points inside of the polygon. Is there like another formula to like compute this? Number of integer points inside simple polygon. Number of points inside the shape of the Cartesian plane. Given a simple polygon constructed on a grid, points, so that all points on grid pick some formula to calculate the area. Yeah, but okay, but how do you get the number of points? Number of grid points inside a sufficiently fat figure approximately equals in this area. Oh man. Too much mathematics. Leave me alone. Algorithm to calculate the number of lattice points in a polygon. What is a lattice point? Number of lattice points. What is a lattice point? I think I saw this lattice point thing in a Project Euler problem. This one is a point Cartesian are integer. Oh, okay. that sounds simple. Number of lattice points is just like an integer. Coordinate. What a pretty question. Since you are talking about Pick's theorem, we'll assume all of the vertices have integer coordinates. Your question reduces to determine how many lattice point lies on a line segment from xy to x2, but that's very easy since the answer stays the same under translation by an integer. This reduced to determine how many. Yeah. Did you not say something about not counting the vertices correctly? Not counting the vertices correctly. I don't remember saying this, but when calculating the area. Not counting, do you mean not doing all the vertices? Because like I'm pretty sure I have all of them. Vertex. So I have 1, 2, 3. Wait, why am I doing this? Can't I just do? I do have like 15 vertices, and in the example I did this in the beginning where I counted this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I mean, I'm counting the origin twice, but here I'm ignoring the last one so that I don't have twice the origin. So no, I have all the vertices. I think. Would we get a number less than what is supposed if we count a vertex incorrectly in the area? Will we get a number less if we count a vertex incorrectly in the area? Ah, okay, you mean... Okay, I see what you mean. Yeah. But the most confusing part is if I do the shoelace instead of like the other form of the shoelace, like the area is greater, so it's 84. It is, nope, it is 84, but if I do this version of it, it is 42. Then you count more, but like I'm doing this operation on the same number of vertices. So in this version, I'm counting more. I mean, I know I'm counting more, but I'm going over the same exact vertex. Huh? Like this is the same loop, just different stuff in the loop. Is the last or first vertex 20? Nope, definitely not. So if I find the vertices, yeah, it is supposed to be 62. And so this is all the vertices from 0, 0, and yeah. I did check them manually when I first parsed the problem. So those are correct. I can double check, but I think they are correct. Yeah, I'm roughly double checking again, but no, it's fine, I think. Yeah, it's supposed to be 62, and I'm confused about this where... Yeah, maybe I did not understand something in this, but... wait, otherwise the answer is the greatest common denominator of xy plus 1. We prove this by showing A that any lattice point between 0, 0 and xy must be a multiple of the least lattice point, and B, any lattice point must have the coordinate that factors xy. Finally, be careful not to double count the vertices as you walk around the polygon. Your question reduced to determining how many lattice point lines on the line segment from x1. For each side AB of the polygon, the number of lattice points is equal to greatest common denominator of where A is equidistant. I do not understand this. Like, what the greatest common denominator? So the highest number that can divide both numbers, and he's doing this on the difference of the coordinate. So wait. So then he just has a vector for the edge. It is centered at 0. Yeah, I think. And he's doing the greatest common divisor between the x coordinate and the y coordinate of this. Oh la la. I do not understand this, but I still would like to try it. Math. I think we have math G greatest common divisor, yes, of vertex. So it's next x minus vertex x and next y minus vertex y, and this is plus 1, and so I don't know, inside is 0, and then inside plus equal this plus 1. Yes. That looks like magic to me. Println inside 52. Et okay. And Pick's theorem was so 52. So it was 52 plus I think there was 38 on the edge, right? There is, yeah, 38. So 38 divided by 2 minus 1. Oh. Again, it's almost 62, but not quite. What if I do the absolute value of this? Will it change? Nope, still 52. What if I don't do plus 1? It is 38. Okay, that's a bit strange. And this definitely doesn't work, huh? Nope. Suppose the integer let I be the number of integer points interior to the polygon, and let B be the number of integer points on its boundary, including both vertices and points along the sides. Then the area of this polygon is this. Funny, be careful to not double count the vertices as you walk around the polygon. For each side AB of the polygon, the number of lattice points is equal to... I'm trying to find the number of lattice points that strictly lie inside the boundary. I know Pick's theorem is this, where A is the area of the polygon, I is the number of lattice points that lie inside the polygon, and B is the number of lattice points that on the perimeter of the polygon. You can easily find the area using the shoelace formula, but I'm not sure how to get the points on the boundary. I'm not sure how... Yeah, but this is again for like... Can AI get depressed? What the fuck? AI aren't built... Okay. Wait, I got distracted. I am getting distracted. So, val inner area is equal to Gaussian area points plus 1 minus ln 2. What is Gaussian area? Gaussian area. Gaussian function, Gaussian distribution. Oh, Gauss area. Ah, Gauss area is just the shoelace thing, no? Plus 1 minus ln divided by 2. It's just Gauss. Is there a difference between Gauss and Gaussian? Also known as Gauss area. Okay. Let's try what you're saying. Huh? So the shoelace formula was this. Gauss is how you cross multiply. Okay, so boom, boom, boom. So this is 42, and then you're saying wait, no, the shoelace formula was this one. So this, and then you're saying this plus 1 minus, I guess by len you mean the number of vertices. That should be -1 because I have the first one twice in there. And this whole thing divided by 2. That doesn't look right. Yeah, no, 78. 78. Wait, was this the shoelace formula? Yeah, I think that was the shoelace formula. And this is supposed to be the same thing, but it's not in my case. Oops. Yeah, and here as well, it's not. Did I copy the shoelace? I mean, this correctly? Because strange that it's different. For each element. And it's. Yeah, no, that's correct. Hmm. Shoelace formula for integers. Shoelace formula, shoelace formula. Shoelace formula. Pix shoelace. What the fuck is this? Two important methods for computing area of polygons in a plane are Pix theorem and shoelace formula. For a simple lattice polygon, a polygon with a single non-traversing boundary cycle, which is what I have, all of whose vertex coordinates are integers, which is what I have, with I integer points in its interior and B on the boundary. Pix theorem computed area is this. Okay. The shoelace formula has various formulations, but in the version I'm going to use, it's a sum of over-oriented edges of the polygon. Let's say, yeah, denote the edge of the polygon that connects 2 points, yeah, oriented in the clockwise direction. So that if you try along this line segment, then the interior of the polygon will be on your right. Sure. Then according to the shoelace formula, the area is yeah. The shoelace formula looks messier than Pix formula, but it is much easier for computers to evaluate, both because polygons are generally represented in computers by their boundary rather than by the points they contain, and because there are often many fewer boundary edges than interior lattice path points. It also doesn't need the coordinates to be integers, but since these two formulas produce the same value, it would be interesting to see a more direct relation between them, explaining one formula in terms of the other. Proof of the shoelace formula. Yeah, okay, this is more like... This is not what I want. And what about... is there an easy way to count if a point is inside the shape? Because, I mean, there is the stupid method of looping over every single point, but that will be a bit too much. Uh, uh, Look into the link I've posted above. I think this is exactly what you were looking for. But I don't see your link. I mean, I see your val inner gauss area points. This is what I see. I see val inner area Gauss area plus 1 minus length divided by 2, but I don't see the link. And also, I tried this, but it didn't seem to work. So Gauss area, I think, is just the shoelace thing, shoelace formula, which is what I have here. And then I did your thing where I did the area plus 1 minus the length of the vertices divided by 2. And I mean, I assume that the length of vertices is the len in your stuff is len of vertices, but maybe I'm wrong. So yeah, I don't know. Are you just not allowed to post any links in the chat? Yeah, I'm not sure. Look into the link. There is no link. This was wrong as well, huh? Yes. How about not dividing by 2? Still. Then still not correct. Hmm. Shoelace algorithm. Shoelace theorem. Shoelace formula. Okay. Shoelace method. Out of area of a triangle. Oh, did this? Okay. Mm, no. No. Mm. Another simple method for calculating the area of a polygon is the Schooling formula. It gives the area of any simple polygon in the sum of terms computed from coordinates of consecutive pair of its vertices. Unlike Peake's theorem, the Schooling formula does not require the vertices to have integer coordinates. Mm-hmm. No, don't give me the solution. No spoilers. I'd rather fail than get the solution. Um, um, I think maybe like after Advent of Code, if I still don't find the solution for some problem, maybe I will look it up and try to learn something from it. But until the end, I don't want to look at the actual solution that someone else came up with. An area. Let's come back to the basics. So that's 84. And I have 22. Too many. Mm. Uh, oh, actually, did you meant like the length of the edges? Like so, like the total perimeter. I mean, like so. Oh, that looks promising. Oh. So the whole perimeter is 38, yes. I already did this. I already did this like 30 minutes ago. I already did this 30 minutes ago. Ah. And so I'm missing like 4 of them. And I already tried this, huh? So, yeah. I already tried this, but it was this try. If I remember correctly. Yeah, already tried this, huh? This is not the correct answer. Why is it 84? Can I loop over the vertices and just... Can't I just decrease the shape by 1 in those cases? Yeah, that won't do much. That won't do much. It will be just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, no, that's not good. I don't know. Alright. I'm not gonna spend 5 hours like yesterday on this. How is it going? I'm about to rage quit. That's how it's going. It's going great, you know. Yeah, no progress. Still don't understand why, like this is the shoelace formula and this is like the alternate version. And I don't understand why one is greater than the actual answer and one is lower. Like, that doesn't make any sense to me, but yeah, oops. Can I have the absolute value of this, maybe? Oh, that's different. That's different. It's stupid to get the absolute value of this, but out of paranoia. What if I measure the size? 90. Okay, I'm doing random garbage. I am doing random garbage. Hmm. Oh, wait. Oh, fuck me. Maybe. Uh, fuck. Because I have the origin at the start and also at the end. And maybe indeed I'm missing one vertices because of this. Uh, can I do vertices is equal to vertices, but I ignore the len vertices -1, like so. Cannot do this. Syntax error. Expected non-operance. Okay, let's do. Yeah, I guess we can ignore the last comment. Comments, because it will definitely go back to the beginning, or at least we assume it will. So this is modulo len vertices. Yeah, I'm missing something, which I guess is this one. Okay, but now I want to make sure that println of vertices is actually what I want. So from 0, 0 it goes, and then the last one is 0, 2, which is correct indeed. And then I want to do println of vertex and x. I mean, I don't think this will solve my problem, but it will make me slightly more sane. So we do each pair of edges, each edge like this. And at the end, we end up with only this and this, which is fine. Let's do the other one. The exact same answer. Alright. Alright. Can you throw them in some kind of calculator? I mean, I don't think. I mean, Come on, give me some credit. This is like 2 lines of code. But yeah, I can do this. Regular polygon area. Oh, calculator here. Oh wait, no, that's not the regular one that I need. Simple polygon area calculator. No area of a regular polygon. No area of a polygon calculator. Yes. Number of sides. Yeah, but I don't want. I don't want a regular one. Shoelace. The chords. Chords? The coordinates. Yeah, that's what I'm looking for. But you mean compute the area from this? But do it by hand. Oh. Yeah, I guess I can. Python. Oh, this is gonna be annoying, but area to 0. Then area plus equal. So it's 0 times 0 and then minus. I think I'm gonna do a mistake by hand, to be honest, but so the current one is 0 and the next x is 6. And so then it is 6 here and 5 here, I think. Yeah, and then minus, and then this is 0 here and this is 6 here. Do I really want to do this for like, this is just pain. I guess what I could do is edges is equal to like so. Oh, and I cannot edit it. Fuck. Can I print just a comma here? Up, and a comma D. Wait, no. Oh, generating Python code with Odin. Up. Like so, and Python, whoops, Python edges. Yeah, that sounds cumbersome to do, huh? But just for you, I will do it. For v1, v2 in edges, print v1, v2. So that's what we want. Then we need area is equal to 0, and then the for loop, and we do area, and what was plus equal v1 x times v2 y, area minus equal v1 y times v2 x. Oh, yeah, fuck. This is v1 is 0. This is 1. This is 1, and this is 0. And just the area, the exact same thing. So it's not Odin's fault, but I guess what I could do is make a very, very simple example. Yeah, rip. Let's see. Let's do example example simpler. Let's do going to the right 4 times and then, I don't know, just random garbage here. And then going down 4 times with still random garbage, then going left 4 times. Let's just do a cube, you know, and then going up 4 times. And then let's do a example simpler, like so, and then run. And it says, seems it should work with this formula, but there is some computation error. Yeah, I can double check that I didn't make an error, but so it's area is equal to area plus I is the current one and j is the next one, so it's x times y, that's fine, and then minus y, the current one y times the next one x, which is exactly what I have. And yeah, that I also have. But I wanted to do my very simple example. Example simpler. Seems modulo n. What is that? That's to get the next one to loop back around. So you want. So here we can see that the start vertex is 0, 0, but we also want from the before last one to the origin. So of course you have to loop back around the indices, which I think this is correct. And this is exactly what they do in this example to get all the combinations of vertices. And yeah, of course, if I don't do that, I will have index out of bound error. Yeah, index is out of range. So I was like 32, and this is a 4x4. So this looks like 1, 2, 3, 4. Actually, this is not. Yeah. So example simpler is going 4 to the right, and 4 I just do plus equal. Huh? Okay. So I do 1, 2, 3, 4. Yes. Then I go 4 down, which is 1, 2, 3, 4. Like so. Then I go 4 left, which is 1, 2, 3, 4. Then I go 4 up. 1, 2, 3, and 4. Like so. And so just 4 times 4, the area is 16, but actually the formula gets me 32. So the formula is definitely wrong. Why is it? Wait, didn't someone say to divide by 2? You did say that to divide by 2, but it wasn't for this reason. It was in this case, no? Oh, wait. And wait, I didn't comment this, my bad. So in this very simple case, this formula is correct. It is giving me 16, and this is 16. But as soon as I switch to the example, it's not correct anymore. So it works with a simple square. Yeah, that's strange indeed. And if we go back to the example, I think it was 42, so we're missing 20. Yeah, 42. We're missing 20. Where did my 20 go? Where did my 20 go? What if I do, if I change the simpler example to be something like so. So example simpler. So instead of going down 4, it would go down by 2. Then it would go right by 1. Then it would go down by 2. And then it would go left by 5. Down 2, right 1, down 2, left 5. Yes. This is 18. So if all of this is 16, we just added 3. And so this should be 19, but it's giving me 18. So as soon as I introduce like a shape that is not completely regular, it doesn't give me the right answer. And the other way of doing this is still not good, no? I guess. This is giving me 36. Where I'm supposed to go get 19. So this definitely doesn't not work. Yeah, I have no clue how to make this work. So huh. Yeah, okay, I give up. I'm gonna do something else with my life. Here reads, hopefully. Man, I don't want this whole thing to be just me failing every single day after 17, no? It would be so sad. And the worst part is like the problem were getting harder around 12 or 13. And then I don't know what happened, but like for 15 and 16 were extremely easy. And then suddenly like it's like a crushing difficulty, at least for me. Like the levels don't feel. Have you done 10? I did part 1 of 10. I didn't finish part 2. And yes, this was one of the hardest days. It was the one where, yeah, you have to distinguish the inside and the outside of a boundary. So something similar to today, actually. But I haven't done 10. And I haven't finished 12 as well. I don't remember why, actually, this one. Yes, I think my simple thing wasn't working for part 2. Anyway, I'm getting very, very depressed now. 2 days in a row that I cannot do. I mean, I did learn something on both days. I learned Dijkstra on day 17, and I learned that there is formulas to compute the area of an irregular polygon on day 18, which will probably come in handy at some point in my life when you're doing computer graphics or stuff like this, maybe. But yeah, it's a bit sad. Anyhow, I'm gonna make a video about the C programming language because at least that's something I'm good at. All right. Yeah, it was relatively fun. Would have been more fun if I have succeeded, but anyhow. See you. I'll still try the one of tomorrow, of course. Huh? Even if I failed all the next one. Is it a live video? Nope. But no, it's a recording. No, C programming is are like the just regular videos on my channel, and yeah, those are not live. Oh, you mean live video in the sense that there is no editing? Yeah, there is no editing, of course, because I suck at editing and I'm too lazy to do it. And also, I find it cooler when someone can just explain something without any editing. Feels more natural. But yeah. Anyway, see you tomorrow maybe if you want to see me suffer for another day. Be there and yeah. See you.